We need to resolve the given rational fraction into its constituent partial fraction. Let us begin. So first what we'll do, we'll try to factorize the denominator, which is x raised to the power of 4 plus x squared plus 1. Now how to do that? So we'll take the first term and rewrite it as x squared whole squared. We'll take the second term, but instead of x squared, we'll make it 2x squared. However, we have one extra term here, so we'll have to subtract x squared from it. So we'll add the third term to it and subtract x squared from it, such that the second term remains as x squared. Now, in doing so, we immediately observe that the first three terms are the expansion of x squared plus 1 whole squared. So we have x squared plus 1 whole squared minus the extra term x squared. And this gives us the difference of two squares. The difference of two squares, which is a squared minus b squared. So this is simply the factors, the product of the factors a minus b and a plus b. Meaning, we can now rewrite the difference of the two squares as the factors x squared plus 1 plus x times x squared plus minus x plus 1. Fine. Which means that now we have successfully factorized our denominator into two factors. So x squared plus 1 divided by x raised to the power of 4 plus x squared plus 1. So this was the original rational fraction. So this can be also expressed as x squared plus 1 whole divided by x squared. Will take the product of the two factors x squared plus x plus 1 multiplied to x squared minus x plus 1. Now our goal will be to find out the partial fraction. All we have to do, since there are two factors in the denominator, so we'll get two partial fractions. The first partial fraction will be something in the numerator divided by x squared plus x plus 1 added to another partial fraction. There will be some factors in the numerator, we'll come back to that in a moment, and divided by the factor x squared minus x plus 1. Now here, x squared plus x plus 1, this is a quadratic factor. Whenever we have a quadratic factor, then the numerator will be considered to be ax plus b. And similarly, for the second partial fraction, the numerator will be cx plus d. So we're going to label this as number 1. Now our goal will be to find out the value of a, b, c and d. And once we find it, we'll plug in that into equation number 1. And what we'll have is two partial fraction, the sum of two partial fraction. And that's going to be the resolution of the original rational fraction. So let us begin. So what we'll do, we'll take equation number 1 and multiply both sides with the denominator x raised to the power of 4 plus x squared plus 1, such that on the left hand side we get only x squared plus 1, and on the right hand side we will have x raised to the power of 2 minus x plus 1 multiplied to ax plus b added to x squared plus x plus 1 multiplied to cx plus d. Fine. So now what we'll do, we'll expand the right hand side and combine all the like terms. So that's going to give us x cubed multiplied to a plus c plus x squared multiplied to negative a plus b plus c plus d plus x multiplied to a minus b plus c plus d. And then we have the constant term, so that will be simply b plus d. Okay, so clearly we observe here that there are four terms. The first term contains x cubed, second terms contain x squared, third terms contains x, and the fourth term is nothing but the constant term, that's b plus d. Now on the left hand side we only have two terms. One is the constant term 1 and the other is the term containing x squared. Well, what we'll do, we will add two more terms here, but since they are not existent here, we can rewrite it as 0 times x cubed. So this is the term containing x cubed, but since it's multiplied by 0, it means that it's not existing. This will become evident in the moment why we're writing in this particular fashion. Then we have x squared, then we need a term containing x. Since it's not present, so we'll write 0 times x plus the constant term 1. Now immediately on the left hand side we can see there are four terms, one containing x cubed, one x squared, one x, and the other constant term. So what we'll do, we'll equate both sides. So when we equate both sides, we're going to get some equation. On equating, so the first equation will be a plus z, that's the coefficient of x cubed on the right hand side. Clearly this is going to be equals to 0 because the coefficient of x cubed on the left hand side is 0. So this gives our first equation. Let's label this as number 2. Then moving on, we have negative a plus b plus c plus d. So this is going to be the coefficient of x squared on the right hand side, and this will equate to 1 on the left hand side because the coefficient of x squared on the left hand side is 1. Let this be equation number 3. Similarly, we have negative a minus b plus c plus d. So that's going to be equals to 0. That has been number 4. And we have one more equation, the constant b plus d. So that will be equals to positive 1. So this will be equation number 5. So where we have 4 unknown values, a, b, c, and d, and we have 4 equations. So using any standard method, you can find out the value of a, b, c, and d, which I'll be leaving as an exercise for you to try out. I'll be stating the values here. So a comes out to be equals to 0. Then b comes out to be half. Then we have the value c. C also comes out to be 0, and d value comes out to be 1/2. So therefore, we have successfully obtained the value of the constants a, b, c, and d. What we'll do, we'll substitute this back in equation number 1. So therefore, we have, so in place of a, we have 0. So we have 0 times x added to half divided by x squared plus x plus 1. And we have 0 times x, c is 0, plus the d value, which is half, divided by x squared minus x plus 1. So therefore, we have successfully resolved the original rational fraction, which is x squared plus 1 divided by x raised to the power of 4 plus x squared plus 1 into two partial fractions. We have 1 divided by 2 times x squared plus x plus 1 added to 1 divided by 2 times x squared minus x plus 1. And if you want to cross-check, what you can do, you can combine the two partial fractions, and the result should be exactly equals to the original rational fraction. So this is the final answer.